We're now getting into one of my favorite parts about algebra, the concept of linear equations and linear functions. When you look at the word linear, you should immediately notice that you see the word line inside of linear. That's because all linear equations or linear functions, they will all be straight, that's a G, straight lines. So they will all be straight lines, and those can be either continuous straight lines, they could be discrete straight lines, but they will all be a straight line. They don't have to be necessarily positive like what I drew right here, but they could be negative straight lines, but they will all be straight lines in order to be linear. Okay, you picked up a piece of paper in class. This piece of paper needs to be folded so that you have 4 different sections. So you're going to have 4 different sections on your piece of paper. Those 4 different quadrants, you're going to put numbers in each one of them. So 1, 2, 3, and 4. So this is going to be a foldable that you will then glue down into your notebook. So we're going to have 4 different things that we're discussing, and those are those 4 points from our content objective. That's linear graphs, linear tables, linear verbal statements, and linear equations or linear functions. Okay, in box 1, I want you to write the word graphs and then put linear graphs are. We're going to have an example and a non-example. So linear graphs are, we've already talked about this, straight lines. And those can be continuous or discrete. Okay, so here's an example. I'm going to do 2 different examples, a blue example and a red example. So here is a blue example, and then here is a red example. Maybe it looks kind of pink. I'm going to do a blue non-example and a pink non-example. So here's my blue non-example. That's actually something called quadratic, which we will get into later. And then you will remember these from what we did in the last unit with scatter plots. So we have a blue example, straight line, and a red example, just a bunch of dots in a straight line, and then we have a blue and a red non-example. One's quadratic and one is just a scatter plot. Linear tables. This is in box 2 for tables. Linear tables have a constant delta x and delta y ratio. So I'll explain what that means more in class, but have a constant delta x and delta y ratio. The delta x is always the change between the x values. That triangle means change. It's the Greek symbol delta, and delta means change. So delta x. We're trying to figure out what the change between our x values is. So that's why we make those little arrows, and we jump, and we say the change between -1 and 0 is +1. Between 0 and +1 is a +1. Between 1 and 2 is a +1. So we know we have to figure out what that constant ratio is between our x's and our y's, so we need to find our delta y's as well. With this problem we see we have from 5 to 3 you subtract 2, from 3 to 1 you subtract 2, from 1 to -1 you subtract 2. So since all of these are the same and all of these are the same, we know that we have a constant x, or delta x and delta y ratio. Our non-example is a little bit more complicated. We see that we have a constant change, a constant delta x of +2 between our x values, But then our delta y, our change in our y values, between 3 and 4 is a plus 1. Between 4 and 6 is a plus 2. So that right there is going to tell us that we do not have a constant delta x and delta y ratio. And like I said, we'll be further explaining this and practicing this concept in class. In box 3, equations. Linear equations can be written in the form ax plus by equals c, or y equals mx plus b. Lots of letters there, and we'll explain those in class definitely. But here are a few examples and non-examples of linear equations. So these are all linear equations. Y equals 2x plus 1, because this is written in the form of y equals mx plus b, where 2 is my m and 1 is my b. We also have an example of negative 3y plus 5x equals 6. And that's an example with an a, b, and a c. Ax plus by equals c. But it might just be switched around a little bit. But then also this one, so 5x equals 6 minus 3y. And so these two problems, the last two that I wrote, these are actually the same problem, just written in a different order. So we see that this one up here has x and y on the same side and can be written in the form of ax plus by equals c. And then this one down here has x and y on different sides, but it can still be manipulated and moved around so that it can be ax plus by equals c. Some non-examples. A non-example would be x squared plus 3 equals y. And the reason why is because you have a squared. If there's something squared in it, it's not going to be a linear equation unless the square is able to be canceled out. And we'll see examples like that in class. Another non-example would be the square root of x plus 4 equals y. So that's another non-example, because in order to solve for that, we would have to have some exponents other than 1 involved in our problem. So your reasoning y is right there. Also, here's another one. 1 over x equals y. That's not a linear equation because you have x as your denominator. Verbal statements. This goes in box 4. In order for a verbal statement to be linear, it must be able to be written in the forms listed for linear equations. So if you're trying to take a verbal statement, an example would be the sum of x and 4y is 9. If you're trying to take that and turn it into an equation, we know that we would see the sum of x and 4y. Well, sum means that I'm going to be adding. So I'm going to take the sum of x, so x plus 4y, and wherever I see is, that's my hint that I'm going to be using the equal sign. So x plus 4y equals 9. And this is exactly like one of the examples for a linear equation. We have an ax plus a by equals a c. So we know that this is linear. If something is going to be a non-example for a verbal statement, it would have to have those components like mentioning squared or square root or any exponent other than 1. So non-1 exponents. That's it for now. We'll have more examples and practice in class. Come prepared for quiz 10. That'll be at the end of class on Thursday.